Welcome back to digital class, and now we are looking at methods of making magnets. Now, we actually can create magnets using magnetic material. Let me just highlight the word magnetic material. Can we create magnet using non-magnetic materials? No. Okay, we can only create using magnetic material. Then with that, what are the magnetic materials that we learn in our notes here? I told you, right? INCS. INCS. And what are the I? I is iron, N is nickel, C is cobalt, and S is steel. Okay? So, and how do we remember this? In class, we study. Okay? In class, we study. So, INCS. Now, there are two ways of making magnets. The first way is the stroke method, and the second way is the electrical methods. So let's look at the stroke method first. So basically, you can, as the diagram show, you can hold a magnet, then you rubbing on a rod, on a magnetic material. As you can see, example here is steel rod, okay, which is the S. So let's look at the description here. We stroke a rod made of magnetic material, example INCS, with only one pole of a magnet. Means that if I use N, north, I just stroke using north. I will not alternate like north stroke, north south, no. North means north, south means south. From one end to the other repeatedly in the same direction. Means what? Means that if I have this, example, this is the bar magnet, this is the steel rod, I will do it on the same direction. Means that left, example, left to right, left to right, left to right, left to right. Okay, I will not do like this, left right, left right, left right. No, that's wrong. Again, one pole of the magnet in the same direction, to the right, then up, left to the right, up, left to the right, left to the right. Okay, again, we will not left right, left right, left right. No, that's wrong. Okay, and you can do it for many times, and one of the good example here is 20 times. Okay, now of course you can't do it like 1 2 3, that's all. No, you must do it many times, and the minimum probably a suggestion is 20 times. Okay, and with that the rod will become magnetized. Now the key thing here is the greater the number of strokes, the stronger the magnetism on the rod. Okay, we call it as a magnetized rod because now it's magnetized already. Okay, means that if you do it more times, the magnetism will be stronger. Okay, and as I have actually shown you how this works, now look at here carefully. I told you, right, with only one pole, so you can choose any pole and the same direction. So example, if you use S as the pole that you go down, then you go to this direction from left to right, then this side of the steel bar, or either steel rod or whatever magnetism material that you use, here will become south because you use south to go and rub it. Okay, so it's south. On the other hand, if you use north and you go left to right like this, then here will become north. So you must see here, south, then here becomes south, north, here become north. So another example, you can look at the diagram. This diagram is going from the right, as you can see, going to the right to the left. If he using north here, here will become north. Okay, so that is basically the idea of stroking method. On the other hand, we have electrical method. So again, you put any magnetic material here that you like, then you coil with an electrical wire. So let me just highlight the word electrical wire. Coil with an electrical wire around the rod of the magnetic materials, again INCS, with at least 20 times. Now again, you can make it many times, but 20 times probably is the good minimum lah. Okay, so you can see it's the same. 20 times, probably a good one. 20 times, probably a good one. And what happens is now you need to connect it to a battery. You need to connect it to the battery. And when the circuit is closed, now what happened? It will become a temporary magnet known as electromagnet. Okay, this is called electromagnet because it's connected to battery, right? And it's like electric, then you call electromagnet. Okay. Now, what happened is that when the electricity does not go through the rod loses its magnetism. Means that it needs electricity here. It needs electricity. When there's no electricity, no more magnetism. Okay. Now, what are the ways to make the electromagnet to become stronger? There are two ways here. The first way here is we increase the number of coils of the wire. Why? The greater the number of coils of wire around the rod, the stronger the electromagnet. Okay, as you can see here, right? Here you have different here. If you put more, it will become stronger. Okay? Or the second way of making it to become stronger is to increase the number of batteries connected here. Why? Because the greater the number of batteries connected means that there's a greater electric flow through the wires, coils around the rod, then it will be stronger. Okay, so basically you coil more or you add more batteries. Okay, and with that I just want to bring you back to the ideas here. So I believe you still remember what we discussed here, right? Okay, this idea. And you will see that they use the word electromagnet here. Okay, electromagnet. Now, why do you think that this system needs to use electromagnet? Okay, why? It's because again I told you, right, they'll put all the things here, the magnetic and non-magnetic, they want to separate. Then it will go because there's there's magnetism. The magnetic material will still be attracted here, but the non-magnetic materials will be thrown here. Okay, but why it wants to use electromagnet is because electromagnet is good, that it can make it uh, uh, it can have the magnetism, and it can also lose its magnetism whenever they want. Okay, because they are connected to what? Electric, right? When they want a magnetism, they connect to electric. If they don't want magnetism, they will just cut off the electric. And why do they need to cut off? Because sometimes they need to what? They need to bring down the magnetic materials also. So when it's here, they will cut off the electric, so that this will lose magnetism, so that the magnetic particles will also drop here. Or else it will just stick and go around and around, right? Okay, this is not what they want. They want to separate. So magnetism is always here. Until here, it will cut off electricity, it loses magnetism, then the magnetic particles will drop here. And that is why they use electromagnets in separating the magnetic objects and non-magnetic objects. Why? Because we can lose magnetism at any point of time they want. Or else you just stick there, and how can you separate? How can you take it out? Okay? And that is why we have something called the electric method, the electromagnet. Okay? So I hope with this you learn something. And also let's move on to the last part, which is demagnetizing a magnet. Now, since we are able to create a magnet, we are also able to demagnetizing a magnet. This basically means that we can help and make the magnet to lose its magnetism. Means that the magnet will no longer able to, not no longer, it will not be able to attract something as good as it was before. Okay, so that's why I say that your mom maybe will say that, hey, don't drop the magnet, or else it can't work that well anymore. Okay, so there are three ways that we can demagnetizing a magnet. So the first way is called hammering. Second is dropping. Third one is hitting, something that's very simple that we can do. So the first way, hitting a magnet with a hammer many times. So we have a magnet, we just hit for many times. Okay, of course, you can just name it like how many times. You can say 20 times. Okay, also can. Now, second way is dropping. So you drop a magnet on a hard surface. Now, let me use the word hard surface because if you drop on a soft surface, it doesn't really affect it too much. Hard surface, paka. Yeah, okay. Again, many times you can just drop it for. Again, many times you can just put 20 times. And the next part is heating. If you heat a magnet over a flame for over a long period. Now you can decide how long is it lah. Okay, don't say just 20 seconds, 10 seconds. No, no lah. Okay, as you can say maybe 5 minutes. I think it's quite long. Then of course the magnet will lose its magnetism. Okay, so in this video we learn how to create a magnet and how we demagnetizing a magnet. And I hope that if you want to try at home, please ask for your parents' guidance. Don't do it yourself. Okay, thank you. See you. Bye bye.